Professor. We are Group 2. Our team members are Xuanjun, Du Yu, and me, Huang Lide. Our topic is Cloud Ticketing System. This project originated from the ticketing system for JetChew's concert. At last December, the ticketing system for JetChew's concerts are handled almost 890,000 people. And after we exploring at internet, we found that this ticket system use AWS infrastructure to handle high concurrency requests. It's really surprised us. So we decided to use cloud ticket system for our project, and our goal is to transfer classroom knowledge into practical application by building a fully functional ticketing system. This is our table of contents. First, I will introduce our motivation and goal and some related system. Next, we will overview our system architecture. Then we will introduce you our front end, back end, and the cloud technology, cloud architecture. And finally, we will demo our ticket system, and then summary our project. First, our project motivation and goals. As we mentioned earlier, our exploration is for Zhou Juan's concert, and it is used tickets craft to sell the ticket, and this ticket craft use AWS for concert ticketing. So we decided to use this for our project. Where core functionality is user registration, authentication, real-time ticket management, and payment simulation. Then application of learning. We apply knowledge of AWS services to a real-world scenario. And then practical application. We will understand enterprise-level system design and enhance our practical system. And before we do our project, we search many related search and market analysis. Then we found the backend nodes of Google and the Ticketcraft system architecture. Ticketcraft system architecture is like this. This is the AWS. This image is provided by AWS. As you can see, there are many EC2 and elastic load balancing, and this is UI, and it is used DynamoDB, and we will simplify this image for our project, and we use EC2 load balancing and DynamoDB. And what is our challenge? Our challenge is to handle the high traffic load and high traffic load. So high traffic load is our main challenge, and this is our solution. We will use load balancer and many EC2 for horizontal scaling to handle high traffic. Now I will give you our system architecture overview. First, front-end interaction. We use Flex framework to interact with our front-end HTML and DynamoDB. Then our core functionality will be login event selection, seat booking, and payment simulation. Our cloud technology will use KBase, load balancer, EC2, and DynamoDB. First, I will introduce front end. This is our HTML, and this is events. Events. We can choose very events at this HTML, and this is fail. If the ticket is sold out, it will be fail. Next is login. This is our HTML for login, and this is payment. We will you need to input your car number for buying ticket. And the next is seats. Seats HTML. It will be many seats for us to choose. And the success engineer. If we if we if our if my if our payment is success, it will be like this.
Now for the backend part, we are using Flask and DynamoDB to build an event seat reservation system. It includes features like user registration, login, event browsing, seat selection, and payment. First, we use Flask to create a web application and connect it to the AWS DynamoDB database. We create three tables to store user information, booking information, and order information. For user authentication, we use the SHA-256 algorithm to hash password for security. Users can register for an account and log in to the system. For browsing events, users can view a list of events and select one they are interested in. For seat selection, we use JavaScript to dynamically update seat status, allowing users to clearly see which seats have been booked. Finally, we are integrate a payment process so users can complete their seat reservation. DynamoDB is a great fit for ticketing platform because excels in three key areas. First, it can handle huge spike in traffic, ensuring a smooth experience even during big event launches. Second, it scales automatically, meaning it effortless adjusts to changing demand, eliminating manual intervention. Finally, it boasts lightning-fast read and write speeds, crucial for securing low sought-after tickets quickly and reliability.
Okay, now I'm gonna introduce our cloud techniques and the Kubernetes structure. And first of all, we has to be honest, we have meet some problems, so we cannot build up the EKS service. Cannot build up the EKS service. So yeah, so there is some strange thing in our project, but we finally we finally make up all the things. So don't be too careful about that. And yet, even though EKS is not working, but we still find another way to run our Kubernetes cluster. So yes, the thing is a success. And the first of all, the load balancer is required to handle a lot of data traffic or web traffic. Yeah, and it is very important. And also, we need a lot of EC2 instance to handle our work, and also DynamoDB to store data. And this three is in AWS platform to yes. So, but this is if there is just this thing, I think the whole project will be too simple. So we also made a Kubernetes cluster in our project to manage our EC2 instance and our works service. Yeah. So to make our project more flexible, to give our project more flexibility. Yeah. And and this is our architect. We use native Kubernetes structure and also combine with the AWS platform service. Yeah. The reason why we can use EKS is because when I try to build up the node group and all the thing is falling and I still we cannot find the reason, so we gave up and try another way. The way we build up Kubernetes cluster is to use lots of EC2 instance and set up the master node and worker nodes to combine all the things together. Yeah, and in this picture we can see that, and here the internet, the web traffic, when the web traffic comes in, and it will first go to AWS load balancer, and when it go to the AWS load balancer, maybe HTTP or HTTPS, and it will feed the 80 port or 443 port, and it will be transferred to the node port, and the node port is like a gateway, and the gateway is a interface on all the EC2 instance, and all the when I indicate a node port to the cluster, all the EC2 instance will have a port, and and this port will be assigned to all the EC2 instance. And now if we connect to the EC2 to any EC2 instance with this port number, and this port number will connect to our service. Yeah. And so node port is like a gateway to connect outside and inside. Yes. So when the web traffic comes in to the EC2 instance, and EC2 instance will the web traffic will be arranged by the cluster, and like a load balancer, but or Nginx, proxy manager, and yet all the EC2 instances have lots of pods, and each pod can handle lots of requests. Now, so if we have more EC2 instances, more traffic can be handled, and with more pods, more traffic can be handled too. And in the pod, we have it is a container running runtime, and a pod is a container runtime, so we have to build up an image to transmit in our project front end it combined with front end and back end, and so yeah, so the group member who do the front end and back end who do the front end and back end just will make a Docker file, and the Docker file will make a image under Docker Hub, and the pod can grab the image from the Docker Hub and then successfully deploy it in the pod. Yes, and the DynamoDB is out of our KBus cluster, and the KBus cluster and the DynamoDB is separate from the Kubernetes cluster. It is connected to our EC2 instance with internet connection. So yeah, it is right in the backend service. Yes, so we can combine all the things together in this way. Okay, then we have some demo, and I will show you all the things later. And the first is the load balancer, and the first place the web traffic will meet. And yes, so here we can see cluster load balancer 1 is our load balancer, and it is listen to the HTTP request, and when it receives an HTTP request, it will transfer the request to the node port, and the node port is on the EC2 instance, and our service port is 30847 is here. So the node port will like a gateway to retransmit the request on 30847. Then it will transmit the traffic into the container, and the container will transmit the traffic to the front end and do all the things. Yes. If you can see here, we use US East 1 to be our area. Yes, it's a mistake. We forgot to change it, so never mind. Yes. Oh. Okay, and the Kubernetes structure, we can see cluster master is the master node, and master node will manage all the things like the work assign and or node add or deletion and other things. But you can assign work on the master node, but usually we don't do that. Although we likely to assign all the works on the worker node. Yes. And so you can see here we have one master node and two worker node, and all is running, and you can use it. And EC2 has, even though EC2 has its own public IPs, but we won't use it. It is connect to the internet with the load balancer, so this is not a big deal. And yes, so and it is this 3 node is connect with the private IP. So we have to set the subnet and the PVC in with the SAN setting. Yes, And here we can use some structure to instructions to list all the nodes here. And yes, and the service, the most important part is the last line, and you can see web test 2 is the final node port, and here we can see 30847 is our port number to the outbound traffic, and the inbound traffic is not 80, it is 5,000, but the setting here will not show. Yes.